Thank you very much for joining this morning. We're thrilled to try to moderate this panel this morning. So, as we started to touch with Raman on the sustainable aviation fuel, what do you see as the key drivers to accelerate the utilization of SAF? So maybe Graham, if you want to go for it.
Yeah, I think the key thing is availability, because it's actually very hard to buy SAF at the moment. And if you take the innovation around it, we're starting to see some significant investment taking place in research and development around how we're going to scale up the availability of SAF. So a number of airlines are doing that across the world, and a number of the energy companies are starting to embark on it. But the problem is it's just not available in many places, and even where it is available, it's started to get bought up by other industries. So sustainable aviation fuel, the same type of fuel can be used with some electricity generation companies and their generators. So I think that's a key bit. So there also needs to be a global approach taken by governments and regulators. You see in the States where they've created a carrot approach. You know, there's significant tax incentives in certain states. I think the case studies around that have shown that that's been very effective in getting very rapid investment taking place in the production of SAF. Whereas in Asia and in Europe, the stick has been used where they're trying to create taxes to entice the aviation industry to start using SAF. But if the SAF isn't available, you know, so I think the American approach actually is proving the most successful right now, where they're creating the incentives for people who are outside the aviation industry to make significant investments in production plants to generate SAF.
Thank you, Peter. So,
yeah, I'll just tag on to that a little bit. Pratt & Whitney, we've been kind of forerunners in the whole SAF industry. We started in 2005 with the Commercial Aviation Alternative Fuels Initiative, and we're instrumental working with the FAA and ASTM International with respect to approving the specifications that we now have today in terms of the biofuel additives that we can add to jet fuel A, the kerosene-based fuel, to enable us to actually have a technology readiness that's safe and enabling us to have a drop-in solution, as we call it, that can fit within the existing fuel infrastructure that we have today. And so, you know, that was kind of a key enabler. And then to the points that were raised, we now need to have large-scale refineries that actually, produce the amount of SAF that we need, the 1.2 billion gallons or 450 metric tons of fuel that we need to satisfy the needs of all of our airline partners. And that is kind of the key challenge, which is really where we need a number of key initiatives, the global policies that were mentioned previously, unified basis so that you don't have one country disadvantaging another. We're all on the same level playing field are critical. We like the incentives approach, as was mentioned, the blender's tax credit, although that incentive expires in 2027, and we need our policy makers to extend that so that people are willing to invest, because by the time you put a SAF plant up and you get it operational, the tax credit is expired even before you're actually making SAF. So we need that unification. And then, of course, from then on, it's just continuing to have things like book and trade and other enablers so that folks can take the climate benefit, while we in the technical side are continuing to reduce the, or I should say, reduce the carbon intensity by going from the current 50% blends that are allowed today to more of what we call the 100% fuel. But it needs to really be in consideration of drop-in versus non-drop-in, where when we say non-drop-in, it's a different fuel spec, which is going to be non-compatible with previously certified engines and aircraft. So all of that is a very complicated equation. It's one of my favorite things to say is that the challenges are complicated and so are the solutions.
And maybe Sabine, additional perspective for the airframer?
Yeah, actually, at Airbus, we have been asking ourselves, so what can be our role into that? And of course, everything which was said is the right things, incentives to build up production capacities. So we think we should be a catalyst. That's actually the role that we've set for ourselves, because of course we're using SAF. We really want to promote it. So then it's a bit of all of that. So for instance, we are working in working groups with ICAO for exactly harmonizing the approaches worldwide, but we are also going in very concrete projects. So I'm just mentioning one, ACT, SAF, which is with ICAO, and then to bring the Latin American countries building their SAF capacity. Another one which is directly investing into funds. So we've created one, for instance, together with Qantas, where we invested 200 million last year to actually produce SAF in Australia, even if we are not considering ourselves to be a SAF producer per se, but we are trying to seed fund and to fund where it's actually helping to set the scene and bring the ecosystem forward. A number of partnerships with airlines, airports to actually go on. So another MOU that we signed with Thailand CP Group, where it's about the new energies coalition as well with CMA, CGM, so the big cargo shipbuilder and ship provider actually, to actually work as well across the sectors to bring the things forward. And of course, we've been talking about incentives for airlines and consumers. Here we try to play the example. And if we look at our own usage of SAF, we actually went into 11 million liters of SAF last year. That was, I think, 2% of the whole production. And it was actually more than 10% of what we need, so we went into that. This year we want to use 15% of our total usage of kerosene in SAF. And by the way, our XLR flying here is flying with 36% the whole week. So that's just to show an example. Of course, we are not the biggest kerosene users per se, but to show the example that it's possible. And of course, that's coming with kind of an investment as well. And if I'm looking at our deliveries or delivery flights, so we are offering to customers 5% SAF in the tank. And so these are all little and big things that we can do. Of course, you talked as well about research. So then it's all about how do we certify a JetX, rather than and finding the right ways of being into that. So it's really about multiplying the initiatives and being present, because it's, as you said, it's a worldwide thing, and we need to actually generalize the availability and the presence.
I think you very well summarized the complexity of the topic, but I think what is very nice to see on that stage is the every participants in the ecosystem, like the airline, the engine manufacturer, the integrator, all bringing the stone to the construction. So this very optimistic view.
Stefan, if I may just add one more point, building on what Peter and Graham mentioned. Just to contextualize this, we're at 0.2% penetration on SAF. And to the extent, to achieve net zero, if we're serious about it, then we're talking about a significant improvement in production and availability and usage of SAF, number one. And I believe there's at least two things that needs to happen to incentivize production. One is incentives, like you said. I think the second thing is likely, I hate to say this, likely more taxation on the conventional fuel to bring it to parity. I mean, one is you incentivize production to lower the price of SAF, but then the conventional fuel price is still 2x or 3x low. I think it probably may need, something may have to happen if we're serious about it, even though I hate to say that's not the right thing for airlines and the flying public. But if we're serious about it, that's a consideration.
Yeah. I don't want to antagonize on the tax things. I mean, if you see the proportion of tax already on the liter of fuel, I think the construction and the various from the various participants making the SAF a profitable business, contributing to the efficiency of the all the parts of the ecosystem is probably more sustainable, if I can use the term, than tax incentive and betting on government. Just to move on, and there's a very good point that you mentioned earlier on the climate resiliency, so trying to adapt that. You mentioned the transformation or where the fleet is going to expand in different environment. Also, we should not underestimate the geopolitical and constraints that happen, changing the flight routes and so on. So transforming the aspect. So maybe Graham, if you want to start, and then we move to
yeah, I mean, we have a desert airline operator.
Oh, okay. So maybe start with the desert.
Operating in that environment does bring its own challenges. We have our first test flights for our license in 42 days' time, and we're very well aware, it has an impact on the engines. And modern engines, I think, the GTF engine from Pratt & Whitney, an amazing engine. The fuel efficiency has been better than it was expected, but everybody's having to put slightly better quality metals in and change the construction of the engines, and we will get there. We will get there around that. I think alongside the climate resiliency, the piece for me that's probably most important and could be the quickest win would be around air traffic control and governmental agreements around, Airbus aircraft. They're just so sophisticated now, but so beautifully elegant in the interface that a pilot, if they have the ability to take a direct routing, which should be available in most countries, very straightforward way, that just can reduce. Many of the airlines I worked with, we were flying 12% too long than we actually had to. And inevitably also the length of those flights, the airspace routing was quite inefficient. So you were climbing at a more aggressive rate than you needed to, and you were descending at a more aggressive rate. So part of what we're doing in Riyadh Air, the SOPs, we're going to try and focus on, lower cost indexes, trying to do continuous descent approaches. But reform of air traffic control and airspace management, realistically, that could reduce the overall distance and fuel used by up to 10%. And the technology is already on the aircraft. In fact, it's brilliantly set in there. The engines love it. I know because I was involved in a program for years. If you fly at a low cost index and you fly in well-designed airspace, you can actually add on a year to the engine shop visit, so and you're not using the fuel. So that's a quick win around. In terms of the engines themselves, I think you're seeing a massive investment from Pratt and from CFM at the moment into putting in far tougher and far more resilient and Rolls components into those. We're not going to see the benefit of some of that until 28, 29, even into 30. Some of it a little bit earlier on the GTF, but they're working on it, and I've no doubt that they will succeed.
Yeah, I'll go on now, and thank you for all of that, because absolutely the operational utilization of the engines is of critical importance to enabling durability. We're looking at this from both. I was a chief engineer for the GTFs, and I can tell you we worked entirely on the performance elements, and we assumed that we would have very similar benign environments to what we have historically experienced. But due to the transformation of the industry, the growth of the middle class globally, we found that we're actually flying in areas that are hotter and with higher levels of pollutants, and that also don't have that modern air traffic management system capabilities that you've indicated. And so it really just, for lack of a better word, tore up all of our engines, not just ours, but all of our competitors. And that was a surprise for all of us when we went to these higher performance, higher operating pressures and temperature engines. And then we coupled that with the harsh environments that we were experiencing. It was kind of a surprise, and unfortunately, it impacted our customers, and we're having to react quickly to address those issues, as you've indicated, with improved coatings, improved materials, and Also new systems that enable us to, basically bypass some of that dirt and dust out of the core of the engine so that it's not entering. I mean, we can get 10 kilograms of dust ingested into an engine after 1,000 flights, which is just an amazing amount, and it's very detrimental to the engine. So all of that, is now what we're addressing. But now, working with Sabina and her team, we're looking into the future, and we're seeing that as we look to that next generation of aircraft, guess what? It's just getting worse. It's over half of the future environment, or the future market space for single-aisle aircraft is going to be in those environments, those progressively hotter and more detrimental environments. And also, we're tracking worldwide global temperatures, and last year was the hottest year on record in the last 75 years globally on average, and then this year's even hotter. So the trend is not helpful for our poor little engines, and so we've got to actually go even beyond what we are today as we forecast for the future. And that's, of course, part and parcel to driving fuel efficiency is one thing, but also climate resilience for that future world is part of what we have to build together. And unfortunately, it is somewhat costly for us on the engine side. So it's part of the overall economics that we have to build in and then address with our airframe customers as well as our airline customers.
Yeah, I think you're right. We have to face it. The climate change is there, is present. And this is why this question about resilience and how do we adapt to the climate change is probably the one very short-term question that we will have to take much more on board even. And you've given good examples. So we've actually done a worldwide map of the airports, and we've looked at more than 300 airports, and in order to spot what are maybe the ones, the hottest, the more difficult ones, and here we might face even limitations. Let's take it, takeoff weight, payload. So we might need to have some shorter term adaptations, and that's for a fact. And then yes, we can work as well. We can work as well on the operational lines. You've given very good examples of shortening the path. Probably we need to be as well even more sensing or improving the weather forecast in order to be able to react, because it's not always going direct, sometimes it's going around as well. And then finding the optimum in terms of efficiency and actually resilience. So these are very concrete things that we will even more have to face, and I think there's a lot we can do with the fleet of today. And of course, engine is at the core, but then it's as well the overall operational environment and how we can react to that. And I think the whole weather and surprising weather changes that we face is something that we face, everybody taking planes at the moment. So here we really have to do something very short term. And then there is as well, of course, global ICAO working groups where we can be active in order to do that, because at the end it's about meeting technology with regulations or overall policies that we have to apply again.
Raman, you want to?
Yeah, I think I concur with the rest of the panelists. To me, I think if you throw in climate resilience in an already complex, multifaceted problem, you've magnified it. I think the average temperature is increasing. On top of that, the distribution of fleet is already shifting to even harsher environments. And on top of that, we're talking about 2/3 of the improvement has to come from SAF. And we're not even talking about 50% blend, right? We're saying if you want to increase or decrease the fuel carbon intensity, you're going to go to 100% SAF. And on top of that, we're already seeing the current generation engines working longer, now, and already seeing there's a proliferation of fleet right now in adverse environment, and they're operating longer. We see that there's a time on wing implication, and that manifests in basically the TCO, as well for the operator. So I think the next gen platform, whether it's a conventional propulsion or something else, I don't think we can rely on just the propulsion alone. I think it has to be a combination, like Sabine said. It has to come from operational improvements, plus aircraft improvements, plus the propulsion improvements, plus SAF. I think all of this working together, I think and the infrastructure to support it, I think that makes my head spin. I mean, I think it's a complex problem.
Absolutely, and I like the idea, like giving the more choices and flexibility in the definition of the routes. We probably enabled by additional like digital ability to manage the air traffic, fluidify the traffic. As a pilot, more fun to choose and the weather condition, what to fly, and have more flexibility in the routes. Another aspect probably on the weight and the material and components in the aircraft, the type of material, the shapes, the aerodynamics. That probably will be a good contributor as well to the improvement of the fuel efficiency and carbon contribution. Maybe Sabine, if you want to start?
Yeah, of course. It's not all about fuel and engines. But yes, of course, we want to be as light as possible. And here, all kinds of materials will be helpful. So we are looking, first of all, to materials. Second, to the way we can design with them. And going from a kind of a sheer application of composite in a way we applied metal before into a composite designed composite is helping a lot. Then I'm just thinking a little bit further. Of course, it's as well about circularity, and we've been just flying a bio-based composite on a helicopter, not on an aircraft yet in a primary structure, but on a helicopter. And here you can actually come to a negative carbon life cycle. So that's very positive. and we hope we can go much further into that. But of course there is other things as well. And you mentioned maybe 3D printing, these kind of things. This can help us much more into bionic design. So hence very much lighter design, looking into what biology is showing us is always helpful. So we have, for instance, a bionically designed partition in the cabin, but we can find that everywhere. If you look at these big parts that we usually actually manufacture from 100% metal, using ALM is just really helpful in the production cycle here. And then, of course, it's as well about the overall shape, and you named it. Mavericks could be good ones to look at. Maybe they're a little bit further out, but if you're looking at the concrete applications of how we see a wing in the future, that's clearly going in very different shapes, much more aerodynamically optimized. And if you look here again to the technology, you need more system know-how then. So for instance, if we go for very wide, very thin wings, then we would need to fold them. So you need a hinge, you need maybe even a system who could help you fold it during the flight to alleviate the loads in certain parts of the mission. So these are things which first, again, we look to the birds and what they are doing. But second, you need to have the right system, or sometimes digital, or even more automatized ways of working in order to be able to do that. So this is clearly things which we are also pursuing, because if we are looking one day for a next aircraft, then it should again bring 25-30% improvement on efficiency and as well on fuel consumption. So then, of course, besides the engine, we look into all the other components, and the wing is the second biggest contributor. And here we can do a lot.
So I'll add on, obviously, in addition to the points that Sabine raised, we obviously are working with the additive manufacturing, and it was actually interesting to hear you call it a biological design approach, because we call it an organic design approach, but nonetheless, with these types of manufacturing processes, you're able to create structures that have a lighter weight and greater capability. And of course, we're exploring those to the foremost, while at the same time bringing in a variety of different lightweight materials, be they ceramic matrix composites or organic matrix composites. But the circularity aspect that was raised is kind of critical. As we start bringing in more composite materials, you start looking at their capability to be recycled, and frankly, it's not as easy with what I'll call a thermoset matrix to do that. So that's where we in RTX are focusing more on the thermoplastics, which have that capability to be recycled. And so another element of the design that we're focusing on. But then going into Sabina's point with respect to these thinner wing aircraft structures, that's why we at RTX are so focused on electrification and putting that capability in the engine, because we understand that as you go to those thinner, skinnier wings, for your next generation aircraft, it's really hard to put a 6-inch diameter duct running through the leading edge and still be able to perform, in those concepts. So that's where, electric wing anti-ice that's enabled by some of these high power systems that we're building into our aircraft and working jointly with Airbus in the EU context with our Switch program to enable that capability.
Yeah, I would be optimistic in another way. Like we're not even in 100 years of commercial aviation right now. We're not even in 60, 70 years of commercial jet, aircraft. There's somebody out there in a garage or a bedroom in China or in California or in the west of Ireland who's coming up with innovations that we haven't thought of yet. And I think in the areas around battery technology, we're still really, really primitive, the battery technology we have. I've no doubt that there is significant investment taking place in that. I had a doctoral thesis kid talking to me a couple of weeks ago, doing an interview. He had shown me that there are companies who are very, very advanced in miniature nuclear reactors for turbofans for the generation industry of power, in remote locations that could be applied. And on the composites and materials, again, we're only at the very early stage. I would say we've just invented the wheel, and we're only just reaching in that. So with the pace of technological development, like we're talking about, I know you're going to talk about predictive AI. I did some work on predictive maintenance on the PW1100 engine about 7 years ago. The computer used to take an overnight to churn through the data, and you could do it in 5 minutes now, and the pace that some of these things are happening. So I think we need to think beyond just how we build everything today and just try and dream a little bit and take a bit of time for not research and development. It's actually just feeding into all of the talent that's there in people in their 20s and their early 20s and 30s, because there's got to be better ways of doing some of this stuff, and I think it will surface quicker than maybe we all think, actually.
So I like the dream industry. Raman, if you want to...
Yeah, I used to be a design engineer. Yeah, and so I'm absorbing all of this. This is fascinating, right? I think, similar to the conversation we had, Graham, before walking in here, we're assuming that safety is a given. I mean, I think with all of these improvements, you still need to hit or exceed the safety. The industry has got a phenomenal record of safety, and we got to continue improving that. So with all those technological improvements, you still need to get there. I mean, that's number one. And the second one is, I think I'd like to build on what Peter was saying. We're talking about new materials and new design, new designs and design architectures, if you will. But there are things that can be done taking the data currently available, processing the data. I mean, you mentioned about predictive maintenance stuff. There's a lot more that could be done, with the current data. That is within the realm of today's industry and today's technology. It's not even a transition technology. We have that technology. So we can actually start using that more to achieve the aspirations.
And I think, Airbus with the Skywise products and everything, they've come up with amazing tools for people to actually save fuel, manage their engines. Pratt have done it as well. actually too many airlines don't use it, right? And actually, they pay Airbus a lot of money for it, and they don't use the data, or when it comes out, it sits in silos within airlines, and actually it sits in engineering or just who don't talk to finance or whatever. So again, what we're trying to do at Riyadh Air is we've got a clean sheet. All the software is new. We've been able to pick best-in-class products, and we are making sure all of the data talks to each other, and we are going to do something with it. We're going to give it back to the pilots. We're going to give back to the cabin crew. We're going to give back the engineers, and we're going to try and be able to replay scenarios. Well, if we operated, XYZ route in this way, we could save this much fuel. If we did a lot more maintenance much earlier, we could save XYZ. I think a lot of the tools are there, actually. People are not using them efficiently enough.
You're teasing me here, right? So, but you're right. There is so much data on an airplane. So I think we have 50,000 data points with sensors everywhere, and of course we can use that. We haven't found the right digital business model yet, but we see it really as an enabler, and that's what we're using the data with. And you named it. It's with Skywise, and effectively, yes, we can do a lot in predictive maintenance. And this is actually then as well back to the usage of every component. So the more we can adapt the maintenance and know exactly what happened to a component, we can actually design it for the right missions as well. And I think the one point you mentioned was around how do we use the data, what do we do with it, how can we exchange, how can we put the things actually together. So there's so much wisdom in that it's really just helpful and makes sense.
Yeah, and I'll go on into that. Thank you for your recognition of our systems, and we have an advanced data engine health monitoring system that we have in place, and we're monitoring over 10,000 engines today. And as was indicated, it's a massive amount of data. We're tracking all of these engines, their operational utilization, their configurations, and what that then results in terms of a signature that we're getting relative to an impending issue or failure that would then drive the need for some form of maintenance. And then leveraging our artificial intelligence. Artificial intelligence kind of has a bad connotation sometimes, but this time it's really actually helpful to enable us to sift through these massive amounts of data and couple that with our logistics management system so that we're placing on order the correct components that were going to be needed to satisfy the repairs of those engines as they come to the shop, so that ultimately we can bring the turnaround time down, because the majority of the time that's associated with engine maintenance is associated with waiting for parts or waiting for repaired parts to come into the door so that we can reassemble the engine and redeliver it to the customer. So getting that cycle time down is of critical importance as we look into the future. And to the points raised, we're putting all these sensors on our engines, and as well, with the aircraft manufacturer, they're giving us the operational data. We have some wonderful capabilities that we put into place actually in the A220 aircraft, a prognostic health monitoring system that does the entire flight broadband data acquisition across multiple systems, and it's just flooded us with info. But then again, now we're being able to utilize that system to optimize our capabilities and give our customers that, I would say, tangible, what do you need to do in a very simplistic form without having to route them through all of their engineering technical departments that have to then go sort out and figure out what's going on, but give them something actionable that they can then begin to build upon as they start to plan their fleet maintenance.
And one word to the airline, because you mentioned it, and it's not about finger pointing, but it's really about what you do with the data. And I think you can actually really give very different targets, of course, to the pilots. You can drive it to fuel efficiency, you can drive it to speed, so I think there is really, as well here, as you rightly point, a way to responsibly actually taking that back and into your kind of operating management system, and I think that makes total sense.
And so, conscious of time, just I'd like if you can briefly comment. We talk about the data, the artificial intelligence, about the people who are actually maintaining and doing the MROs of the engine and the airframe and so on, and how that combination of data, of people, maybe location of the MRO facilities and so on, is going to maintain and improve safety? And that would be the last question before we close.
Yeah, like I think Pratt and Airbus, who are the panel, they've been doing this artificial intelligence with the data for 10, 15, 20 years, to be honest. It's not a new phenomenon from then. You can save vast amounts of fuel by intelligently taking the data out of the systems that the OEMs give you, but you have to tell and train your crew how to take that, and you have to change the procedures of how you operate your airline. You know, fly a bit slower, do your flight plans better, do much earlier advanced engine washing and engine maintenance on your engines and on your fuselage. But I think that the industry as a whole needs to get better about, you know, training the people who operate the aircraft and repair them at the front end to do that. We couldn't ask for any better or more tools from the OEMs. They're absolutely fantastic, and they've had dashboards. You can get dashboard about anything in real time. I think it's actually more about using that data and then changing standard operating procedures in airlines to make people use it. Some airlines are doing it, and then others are flying these things around as if they're Sebastian Vettel in a Formula One car, you know. So like which doesn't make any sense, you know.
This is true music to my ears, Peter. I mean, it's actually, you know, really the case. And we talked about the next generation. You know, we have a very strong and very experienced, crews that are in our airlines. But then again, this digital information brings on a new skill set that's going to be required to actually be able to understand and utilize that digital information appropriately, because it is complicated. But I'll just reinforce Peter's points. You know, to the extent that we can support, you know, obviously we have the tools and capabilities with helping with training so that we can continue to develop that workforce to improve the maintenance. And, you know, there, as you point out, there are airlines that really have that capability, and then there's a number that don't. And I'm just speaking from the engine perspective, and I'll let Sabina comment on the aircraft side.
Yeah, we talked about predictive maintenance and all the data that we can use. Your question was about the people and what can we do for them. And then, of course, in this whole MRO environment, a lot is here as well on digitalization. So we can have supports much more digitalized when it's about repairs, how to find the right repair to the right area. So there's loads of means, or we always have these nice projects where we let drones do the inspection flights. So I think there will be more coming up. And we also see, coming back to maybe the point of resilience, we have requests in certain areas of the world to look at much more automatization on the ground. So how can we improve the ground support? Maybe we don't have enough people anymore in a couple of years on the airports. And these are things that are opening completely new questions as well. How much do we invest into the ground side of things, automatization, robotics, whatever, in order to make that much more fluid? And I think especially these days after COVID, where not everything is as fluid as we were used to it, give these questions in addition to the pure operation of the aircraft flying.
I think I visualize this, Stefan, in concentric circles. I mean, we talked about all the using the data, you know, the aircraft data, the engine data, operating condition data, and putting that together to get some insights and providing it to the airlines. And the airline standard operating procedures needs to improve to be able to use all that. I'm just assuming that those are all going to be a given for the next gen platform that needs to happen, you know, to achieve the aspirations. But then beyond that, I think it needs to go towards, you know, the air traffic stakeholders need to be, you know, more digital and AI enabled as well to be able to guide and, you know, to be able to generate all those operational efficiencies we're talking about. And then if you push that forward in the long run, when you're talking about newer architectures like hydrogen, for example, we're talking about the infrastructure, the data related to the infrastructure, the liquefaction of hydrogen at the airports, the charging stations and the power grid, and that the related data for that at the airports. So now that's the fourth concentric circle where you've got to use data. All of these need to come together to be able to achieve what we're talking about.
And the highest level of safety. And maybe to close, if you want to say like 1 minute, like reinforcing like the key messages and what you learned during the panel and what you would like the audience like to remember.
Yeah, I suppose from my perspective, we're lucky. We're brand new, so we're able to do everything from scratch, and that helps us be sustainable. I think the industry needs to be more open and global, and I think the air traffic reform is significant. I think the one thing I've learned is the airlines that are really good at being sustainable equals normally saving fuel. You'll generally find they're very safe airlines because actually they're more organized and they're flying probably in a more controlled fashion. And you'll often find they're also often the most profitable airlines as well. So sustainability actually really helps safety in airlines and also helps profitability. So it's a perfect marriage. And I think I'm very optimistic about the future. I think we're going to see advances in technology that we can't even consider today. And they'll probably come much sooner than we think, because the tools are there for kids now to do things that we could never have imagined even 5 or 10 years ago.
Thank you.
So, to highlight on your point, we're exploring, we're casting a broad net. We have a wide range of technological advancements that we're currently importing into the current fleet, but also as we look into the future. And alternative energy carriers, be they sustainable aviation fuels with 100% or hydrogen, all of that, underpinning all of that is a non-negotiable, and that is safety. And so as we look and cast this wide net, that's one of the elements that we cannot forget and will not forget, because in the end, we are committed to making our industry and supporting the industry's drive to be sustainable or more sustainable. But nonetheless, we are not going to achieve that objective by compromising on our safety.
So first of all, I would really like to thank you, because you've shown such an enthusiastic way of putting actually the ecosystem together. It is about all of us, the airlines, the OEMs from engines, other partners, and then to the aircraft overall, and of course the environment, be it ATCs, be it the governments and policies. For me, the crucial point again is, and we've discussed about so many different things on the panel, is it is not the one thing that we can put and then we have the solution. It will be around newer aircraft, better sensing and all the systems around. It will be about more direct flights and better operational solutions. It will be about SAFs and all the kind of incentives and mandates that we need to make it happen. And of course, it will be also about technology and newer technology, new aircraft types. We haven't talked about hydrogen so much today, but it is actually all this together which gives us a chance to make it happen. So let's take it.
Thank you very much. Raman, if you want to add a word?
Yeah, I mean, first of all, I applaud our industry for taking on this lofty aspiration right head on. I mean, that's very exciting. I think the market will clear 2050 or later, right? I mean, it's always cleared. Air traffic is vibrant, will continue to grow. I think the question is what combination of technologies, are required to get to that aspiration, and that's got implications. Is it going to be with this, what combination of sustainable fuel, or what percent penetration of that is going to be used? Is there going to be a business model change going forward for the stakeholders involved? I think there's all the stuff that we talked about in the trade space. I think the market will clear, as always clear, I think. So some combination of these things will happen. In the worst case, net zero aspiration could get pushed out if the industry could not solve the problem. But the market will clear. But I think the point that I think about is each of those elements in the trade space has got implications for the stakeholders, the OEMs, the airports, the airlines, and a lot of those implications. And that's all I would say.
So thank you very much. Very happy of this enthusiastic and optimistic, promising discussion today. So thank you very much, Sabine, Peter, Graham, and Raman. And thank you very much all
Thank you.
for attending.
Thank you very much.